Hello everyone, welcome back to our channel Express VTU for all. Today we are going to solve a very important problem from module 1 of calculus on Jacobians. So first we know what is the definition of Jacobians. Let u and v be the function of two independent variables x and y. So the formula of Jacobians for two variables we write as j of u comma v divided by x comma y. X and y are the two variables for the function of u comma v, or we can say that del of u comma v divided by del of x comma y. This states that differentiation of u with respect to x and differentiation of v with respect to y. So we can write as in term of determinant form, dol u by dol x, dol u by dol y with respect to x and y of the function of u, like that dol v by dol x and dol v by dol y. This is for two variables x and y, but in this question as you can see that there are three variables x comma y comma z. So for three variables, what is the Jacobian formula? Dol of u comma v comma w divided by dol of x comma y comma z. It means we have to differentiate our function uv or w with respect to x, y and z. So what's the determinant formula? Dol v by dol x, firstly dol u by dol x, dol u by dol y and dol u by dol z, like that dol v by dol x, dol v by dol y, dol v by dol z, like that dol w by dol x, dol w by dol y, dol w by dol z. So this is the formula for three variables. So here we have to find the given function with respect to x, y and z, which is equal to x square plus y square plus z square, and v equal to xy plus yz plus zx, and w equals to x plus y plus z. So firstly we have to differentiate with respect to dol u by dol x, dol u by dol y, dol u by dol z. So first we solve for dol u by dol x. So what is the value of u? U equals to x square plus y square plus z square. So first we find dol u by dol x. So dol u by dol x, and differentiate this u term with respect to x. So the differentiation of 2x which is equal to x square which is equal to 2x, here 0 and here 0 because no x term is there. So dol u by dol x which is equal to 2x. Now solve for dol u by dol y. Again differentiate u with respect to y in dol u by dol y which is equal to 0 plus 2y plus 0, because differentiation of x with respect to y equal to 0 and differentiation of that with respect to y equal to 0, and we have to differentiate only this term with respect to y. So dol u by dol y equals to 2y. Now differentiate our third term dol u by dol z. So again differentiate this with respect to z. So 0 plus 0 plus 2z. So dol u by dol z which is equal to 2z. Like that we have to differentiate dol v by dol x, dol v by dol y, dol v by dol z with respect to v. And in another case dol w by dol x, dol w by dol y, dol w by dol z with respect to w. So I'll do it. Dol v by dol x which is equal to, what is the value of v? V equals to xy plus yz plus zx. Dol v by dol x which is equal to y plus z. Dol v by dol y which is equal to x plus z. Dol v by dol z which is equal to y plus x, like that dol w by dol x which is equal to 1, dol w by dol y which is equal to 1, and dol w by dol z which is equal to 1. So put all the respective value to this determinant form. So our determinant becomes a equals to 2x, 2y, 2z, y plus z, x plus z, y plus x, 1 1 1. Now we have to expand this determinant with respect to our row 1 along with column 1. So j equals to 2x had this one and this one, multiply 1 into x plus z minus 1 into y plus x. So x plus z minus y plus x, like that, first row and second column. So 2y, why its minus comes to y? Because this is first row first column, 1 plus 1 which is equal to 2, which is even, so plus is there, that's why we take 2x. Why we take minus 2y? Because first row and second column is there, so 1 plus 2 equals to 3, which is odd, so that's why we take negative. So minus 2y, this and this, 1 into y plus z minus y plus x, like that, 2z, because first row third column, 1 plus 3 equals to 4, which is even, that's why we take 2x 2. So 2z had this one and this one, 1 into y, this is y plus z minus x plus z. So we have to solve it. 2x into z minus y minus 2y, this is minus 2y into z minus x plus 2z into y minus x. So when you solve it, this is 2xz minus 2xy minus 2yz plus 2yx plus 2zy minus 2xz. So this will cancel out, this will cancel out, this will cancel out, which is equal to 0. So our Jacobian value is equal to 0. Thank you.